I like mini computers, which, I mean, it should be pretty obvious. If we take a look around the room, there's the Bendix G15 from 1956, which could be considered the very first mini computer ever, especially when you compare it against the size of machines like the IBM 650 that would have been available at the time. There's the Data 620, the Litton mini computer, a PDP 1144, a whole lot of Centurion shenanigans. I love me some mini computers. They're fantastic. But there are two machines that I haven't really shown on the channel before, and that's these two right here. We have a PDP 1173 in a very interesting state of affairs, and a Data General Nova 1210. Now, the reason that I have both of these out is that both of these machines I'm hoping to get fully functional and on display for VCF Southwest. So let's talk about VCFs right quick, because there's a lot of pretty exciting VCFs coming up. Most notably, very soon, on February 15th through the 16th, is VCF SoCal. And I will be driving all the way out to Los Angeles to attend this VCF event. There's also a pretty interesting machine out there that I'm hoping to pick up and put on display. So if you're anywhere in California, come hang out at VCF SoCal on February 15th and 16th. Also, Steve and Mickey, who are putting the show on, are just like the greatest people ever. So come out and give them a high five as well. Coming up on April 4th through 6th is VCF East, and I did not initially think I was going to be able to make it, but my buddy John needs a little bit of help with some teletypes, and so I may possibly fly up and help him get his teletype booth set up. But whether I can make it or not, if you're in the Northeast, check out VCF East and give my buddy John a big high five and check out his teletypes, because I think they're absolutely brilliant. And then the big one, VCF Southwest, happens pretty much right in my backyard, and it happens June 20th to the 22nd. And both of these machines I want there and fully functional. Now, this PDP 1173 is a very strange one. You'll notice that it's bolted to chunks of wood that look like it was homemade. It is homemade. This is a system that features a lot of very interesting cards from Bowman that I got from Mike down in Austin. Thank you so much for that. And I am slowly building this machine up on Friday nights only with my Discord group. This is something that's pretty much exclusive to the Discord group and the Patreon supporters, because every Wednesday I write up a whole article about what happened on Friday and how far we got and post that over on Patreon. So if you want to know a lot more about this system, come hang out with us on Discord or join the Patreon. You can find a ton of information about it there. I hope to eventually build a spectrometer for it, but we've got a pretty wild graphics card going on in it. We've got this insane vector processor bolted to the side over here. It's a pretty exciting build, and I look forward to Friday night every single week so we can get to work on this. Also, I just like hanging out and chatting with the people. But what I really want to show off today is this one over here. We did take a look at the Model 43 teletype that's on top. I now have the correctly sized paper for it, and it seems to be mostly working. We do have a dead pin in the print head. It's probably just gummed up and I need to take the print head apart. But this Model 43 is really just acting as the data terminal for the Data General Nova 1210 that's below it. I got both of these from Robert down in Austin, so thank you so much for that. And I am very excited about this Nova 1210, partially because, I mean, look at the front panel on this thing. What a gorgeous piece of equipment. But also the 1210 is a pretty rare Nova. The 1200, I think, is the more common one, and it's a little thicker and holds a lot more boards. But the 1210 is this like really compact Nova that only holds 4 boards inside. Now, this particular Nova, I believe, was also used as a controller or something for some kind of spectroscopy. So we have 2 machines here on the table that both were involved in some kind of X-ray or infrared or laser spectroscopy. I love these machines. What an interesting world to dive into. So I really want to get this going. I have a tape drive that goes with it. I have some tapes that go with it. I have a bunch of documentation. But the first and most important thing that we have to do with this 1210 is make sure that the power supply isn't going to light the whole thing on fire. So that's what we're going to do today. We're going to pull it apart, take a look at all the boards, then try to get that power supply powered up, see how healthy it is, and see where we can go from there. This Nova 1210 is a bit unique in that it has a desktop style case instead of a rack mount case on it. This is going to be great for my purposes of displaying it at VCF, but sliding this cover off the front isn't exactly a graceful operation. After struggling with it for far too long, I finally got it free. Next, before I slide all the cards out, let's get this top piece off. I'm going to need this piece off to work on the power supply anyways, so now is as good a time as any to get it out of the way. It's just held in with about 12 or so little screws, and with all of those removed, it just pulls straight up and off. Now the top didn't have to be removed to pull the cards out. That would be a silly design requirement. That's just the order I did things in. All but one of the cards have this interesting black cover over the components. I'm guessing that since it's so tightly packed in there, this is to prevent the cards from shorting out against each other. A very understandable choice because this case definitely gives the absolute minimum of clearance between the cards. But all it takes to pull the forward cards out is just a little pull on the levers to unseat them from the edge connectors, then they slide free and clear. Starting from the topmost card and working our way down, this is an 8K memory stack, and you can tell that by this massive plate right here that this is core memory. Underneath here is going to be a bunch of wires with little ferrite cores to create 8K of memory. I mean, that's awesome. I needed another core memory machine in here. I don't have enough of these. This is very, very cool to look at. You can also see all of the individual copper wires that thread through the individual cores coming out of the side here. That's really awesome. Also, you can see how much circuitry is required just to support core memory. There are some dust bunnies on here, so I'm gonna have to clean this board up along with all of the other boards before we put it in there and give it a shot, but that's very cool. The second board from the top is by far and away the simplest, but also I think it's the only one that's not an official Data General board because it says Custom System Inc. over here. And actually that makes sense because this is a RS-232 multiplexer board. You can see there's two UARTs right up here. And you can see a large majority of it is not populated. I have no idea what else would have gone in all of those. But it's a really simple board, and I love seeing the two UARTs up there. They're TR-1863, I believe, which is the same family of UART that the ADM3A data terminal I have uses. The third board from the top is this one, and as you can see, it's another memory board, but this one's actually a much larger memory board. This is a 16K memory board, which means that with the 8K memory board in the top slot, we have a total of 24K of core memory available on this machine, which is a surprisingly large amount for like 1970. This is really awesome. It is interesting though that it goes core memory board, MUX, core memory board, and then CPU on the bottom. So I don't particularly know why the layout on the backplane is going like that. If anybody knows, let me know in the comments below. But I just love seeing these core memory boards. They're so beautiful. And the bottommost board is the board where all the magic happens. This is the CPU board. And actually, it's kind of surprisingly simple looking. I mean, it's all pretty much discrete logic with the exception of these three big ICs up here. This is a 74181. That's a 4-bit bit slice ALU. I don't recognize these two offhand, but the CPU board is surprisingly simple, but that doesn't stop this CPU board from being any less beautiful. Absolutely gorgeous construction here. I also got two spare boards with the machine. The first is this one, which is just another 8K core memory stack. This looks identical to my other 8K stack, and my guess is that the machine was originally outfitted with 16K total RAM, and it got upgraded to 24K at some point in its life. The other board that I got is this one right here. And this one says basic IO control on it, has a crystal here, a massive crystal up here, and I'm not 100% positive what it does, but I'm pretty sure that this is going to be a current loop board for whatever teletype they had originally had it hooked up to. My guess would be an ASR33 before they upgraded to the Model 43 teletype over there. That's RS-232. So the original loadout of the machine was probably 16K of RAM and a current loop. But it's nice to have these as a backup in case we need them. And finally, this is what we want to focus on today, the backplane and power supply. And they're actually surprisingly integrated. The backplane has the full-on switch mode power supply just on it, on the same PCB, which is an incredibly dense way of doing it. You can see that the entire power supply is just right here. The transformer sits right here, and we have, I think, some diodes right here. And that's it. And then you get 4 PCBs above it. That's how they managed to fit an entire mini computer in the size of an IBM desktop. The front panel is right here along this side, and it also has its own dedicated PCB, and I'm betting that we're gonna need to crack that open because I'm willing to bet that a lot of the light bulbs in there are dead. But that's something that we'll dig into after we take a more in-depth look at this power supply. These big chonkers of caps might need to be tested, and I do want to power it up with no boards in it just to see how things go. On the backside of the backplane here, I'm actually looking for some like nice big lugs that I can put some clip leads on so I can actually load down the power supply so it behaves correctly when we turn it on without any cards in it. It is a full wire wrap pins, but everything is actually etched, which makes it really nice. That means that it pretty much works straight out of the box, but you can then modify it however you need to. And you can see there has been some modifications here. And this has to do with that second card, which is the multiplexer card. And on the back, we have 2 ports, a 9-pin port that had the original serial cable plugged into it, and I'm guessing that's the one that goes to the Model 43. And then we got what I think is a 15-pin. I didn't count it, but we've got this guy right here. And I have absolutely no clue what that one's for, but it is going into this second backplane here, so it is also probably a serial port. Looks like there's only 3 wires going to it, so it's probably just send, receive, and ground. The backplane itself is really fascinating in that it has a card edge connector on both sides. On this side, it goes into the front panel. That makes sense. That's how we're getting power and signals to the front panel and receiving the input from the switches on the way back. But on this side, there's a giant card edge connector that goes to something external. And I actually received a cable with this that went to some kind of machine. I'm guessing some kind of spectrometer would plug into this cable, and that was how this was able to control that spectrometer. Really fascinating, and I'm glad that I have the cable because maybe someday we can figure out what kind of signals this machine was expecting to receive from a spectrometer, and we can either emulate that or find a spectrometer to actually control with this. That would be awesome. But before I go any further, I gotta get the dust bunnies out of this thing. I'm not going to do a deep clean, but a quick run through with the air hose should do the trick nicely. I'm going to give the front panel a quick wipe down though. A little simple green on a rag makes quick work of the years of grime that have built up on this thing. Now that it's clean, let's take a look at those big boy caps. Thankfully, they're all bolted in, not soldered in. That means it's an easy job to just undo the locking nuts and slide the caps right out. Well, all except one. This one runs into other parts of the case, but it's out enough to work on it in place. My method of waking caps up is probably not the doctor recommended method, but I've had really good luck doing it this way. I just hook up my bench power supply and feed voltage into the cap, looking at how much current it pulls. Invariably, sleepy caps like this one pull a lot of current initially, but as I feed more and more voltage into them, the current they pull comes right on down. I often let them charge up and then discharge a couple of times, and once I can see that at about 80 to 90% of their rated voltage level, they're pulling less than 10 milliamps of current, I'm pretty happy. I spent about an hour doing this for all 4 of the big caps, and all 4 got to where they were pulling around 10 milliamps, which isn't perfect, but that should be plenty good. I think we're ready to test this power supply for the first time in who knows how many years, but in order to do that, I have to know, first of all, where to measure so I can see if the voltages are correct, as well as I have to load down 2 of the voltage rails. So this power supply generates 3 voltages. It generates plus 15, plus 5, and minus 5. Now, in order to figure out where I can measure those from, as well as just to kind of sate my curiosity, I need to dig through the schematic. And a couple of years ago, somebody went through and archived a boatload of Data General schematics, and what a lifesaver that is. But also, this schematic is really fascinating. Before we dive into it though, Commodore Z, if you're watching, I want to thank you so much for chatting with me last night about Novas and the power supplies and these things. First of all, I just like hanging out and chatting with you, but also you got me pointed in the right direction, and it was a massive help. So Z, thank you so much for that. But this power supply is a really fascinating supply. It uses 2 UA723s, and that's really not the fascinating part. They look like they're laid out pretty much identical to how 3 datasheet says to lay out a switch mode supply using this IC. That is being used for the plus 5 volt supply as well as the plus 15 volt supply. Where it gets really fascinating in here is with the minus 5 volt supply. I was trying to figure out how they were generating it, and it seemed really weird to me. But then I realized that because they're using a switch mode type supply, there's going to be energy moving backwards and forwards through the choke that they're using to create an LC circuit to smooth out the output voltage. And you can see that on the plus 5 volt rail, they're using L1 here, which is just a simple inductor. And then they have C3 as the capacitor to make the LC circuit to smooth that output out. But if we look at the plus 15 volt rail, they're not using an inductor, they're using T2, a transformer. So that energy passing through T2 is going to induce a little bit of current into the secondary of that transformer. And then they're using CR3 as a half-wave rectifier for that secondary to generate the negative 5 volts. It's a really fascinating way to do it, and I think it's absolutely brilliant. But digging through the schematic here was mostly just to find the capacitors that we need, and that is going to be C3, C9, and C14. So the three 20,000 microfarad, that's these three long boys over here on the right. We can check the voltage levels on those, and I can load them down with, I'm going to use a little automotive light bulb on the 5 volt rail, and some resistors that I have tied in parallel on the 15 volt rail. That should give enough of a load to keep the power supply happy, and then I can run through and check it right quick and see what the voltage levels are. All right, everything should be hooked up correctly. I'm hoping to see the car light bulb come on, 5 volts here, and we're not gonna run it for very long because 15 volts through these resistors are probably gonna overheat them. All right, let's just go for it. Oh, yep. Oh, let's watch that again. You can just barely see the flash of something turning into a fireball right here, just over the edge of my jacket. And then in the next few frames, you can see the smoke from said fireball start to slowly billow out into the room. We did it, y'all. We let the magic smoke out. And sneaky, hidden right inside of here, behind this metal casing, are a bunch of tantalum capacitors. And the only reason that I figured out that there was tantalum capacitors in there is that I can smell it. I can smell the burned tantalum in there. Unfortunately, this looks like it's going to be a proper job to get fully apart, to get in there, to get those out. In order to get that metal shielding off, I need to get the front panel off, and I have absolutely no idea how to do that. So I'm just going to remove easy to access screws until the thing comes off. Removing these little hex bolts and end caps here, yeah, totally unnecessary. Removing all the little board guides and plate next over here, also totally unnecessary. What I really needed to remove was this little locking nut right up here. There are 4 of these around the periphery, and that was it. So why did I film removing all the other stuff? So I would know how to put it back together later, of course. At any rate, with the popper bolts removed, the front panel is loose, but the card edge connector is still holding on tight. I had to get in there with a screwdriver and pry on it to get it to move at all. And of course, this happened.
Not graceful.
Yeah, not graceful indeed. Don't do what I do. Thankfully, I didn't break any switches on the front, so bullet successfully dodged. With the front panel out of the way, I have access to the 2 side screws that were hiding out behind it. There are 2 on the back side as well, but they were easily accessible. With those 4 removed, I then had to move on to removing the 16 screws that went through the face of the metal plate and into the backplane card edge connectors. There are 2 per edge connector and 2 edge connectors per card. It feels like overkill, but it also means that inserting and removing the cards doesn't put any stress on the backplane solder joints, which is quite nice. After those 16 have been removed, there are 4 more screws that connect 2 tabs to the lowercase structure. And finally, with all 24 screws removed, the metal cover can be pulled free. And look at how sneaky that is. Those tantalums are not only hidden behind the metal cover, they're installed practically underneath the card edge connectors. No wonder I had no clue there were tantalum caps on this thing. They were completely hidden. To get them out, I first went through and desoldered them to remove as much solder as possible. Then I followed up with heat from the regular iron and a pair of hemostats to slide them out. Unfortunately, despite being as careful as I could, the heat was not kind to the backplane. In the process, 2 vias were destroyed and a trace was lifted. Nothing earth-shattering, but it appears the glue holding the copper to the fiberglass on these old Nova boards is starting to show its age. At any rate, I managed to get all 8 of the tantalum caps out, and look at that. This is the one that turned temporarily into a fireball. Gotta love those tantalums failing short. They're just 4.7 microfarad polarized capacitors, and I have a bunch of electrolytics that should do the job just fine in their place. I'm going to mount them on the backside of the backplane, though, because I absolutely do not want to try to squeeze them under the card edge connectors. I'm bending the legs 90 degrees so I can ensure I have good solder joints to the traces on both sides of the backplane. It's not necessarily the prettiest fix in the world, but this should absolutely fix our problem and be fine for many years to come. I've got enough of it back together to get the front panel on. That should allow me to essentially bring this thing up. My solution here isn't perfect or beautiful, but there was a whole lot more space on the back side than the front side. I've got the multimeter hooked up to the plus 5-volt rail, so we should see 5 volts on that. This light bulb is loading down the 5-volt rail. My little resistors here are loading down the 15-volt rail. I'm kind of expecting these to overheat pretty quickly, so I'm only going to run it for a very short time. Hopefully nothing else goes up in smoke, but let's find out. Well, we're on. We don't have 5 volts. We don't have any of that stuff. That's not great. We've made it worse. And here is why. This is fuse F2 that sits on the actual backplane. It is a 10 amp fuse that comes right after the full bridge rectifier, and it's completely blasted and blown. Also, it's the stumpiest, cutest fuse I've ever seen. I carry a lot of fuses, but I don't think I have any that are that size, because that's ridiculous. I was able to get a 9 amp fuse that was a little bit longer to fit, so hopefully that'll work, because I didn't have any really stumpy ones like that one. I also changed up my load to a different type of bulb. Hopefully this will put a little less stress on it than something like that headlight bulb over there. All right, let's see what blows up this time. Oh! The lights came on, 5.11 volts. That looks pretty good to me. Let's check the negative 5 volt rail here. Minus 6.9, that's a little off. 15.4. That is bang on for the 15 volt rail. It's a little, maybe a slight bit high, but I think that's well within acceptable tolerances. And for the plus 5 volts here, 5.1 volts. That, I think, is going to be absolutely perfect. Whew! What a relief. And this thing makes a wild noise. Oh, that's awesome. That's so cool. Well, it looks like all that was wrong was this one single little tantalum that exploded, and when exploded, it probably took out that stubby, super cute little fuse right here. But I went ahead and replaced all the tantalums, and in my defense, you can't even see them. They like hide them behind this metal piece here. I had no clue there were tantalums on here, and that's just due to a lack of familiarity with this system. But now I know, and if you're working on a 1210, you know as well that those tantalums are hidden in there and could very well explode. You know, I think this thing is good enough for us to start plugging cards in and bringing them up incrementally and seeing what works and what doesn't. And that's going to be very exciting. And that's what we're going to do in the next episode. We were just trying to get the power supply going in this one. So in the next one, we're going to plug cards into it and hopefully get some blinking lights on the front here. And as I said, I really, really want this machine and the Model 43 teletype to be up and fully functional by VCF Southwest. So we only have a couple of months to get this going completely and sort out the tape drive that goes with it. So I'm pretty excited about this machine, and there's a lot more of it coming up. So I want to thank you all so much for watching, and I hope to see you in the next one.